So it depends how quickly you get your work. So you guys learned about simple machines. We've talked about this back in elementary school. So really we're going to use, you could talk about simple machines in a couple different ways because some are sort of versions of another. But for our purposes, we're going to say there's 6 types of simple machines. There's the inclined plane, the wedge, the screw, the wheel and axle, pulley, and the lever. Okay? All of them are relatively simple devices that allow you to change how you do work. Not decrease the amount of work, but change how you do it. And for each of those simple machines, we're going to talk about how we determine their mechanical advantage. How much are they helping you? How much easier do they make your work? Okay? All right. So today we'll talk about inclined planes. So an inclined plane, sometimes call it like a ramp, it allows you to lift an object to a certain height, okay, with less force, but of course you have to apply that force for a greater distance. So we have here a little diagram. So this, you need to get this box that has a mass of 30 kilograms up this 2-meter platform. So you could do it 2 ways. You can just lift it up there directly, or you can use an inclined plane to help you to move it. All right. So when we are calculating the mechanical advantages, does anyone recall the formula for ideal mechanical advantage? Ideal.
Force times something. Isn't it effort distance divided by resistance distance?
Yes. So IMA, ideal mechanical advantage, is the effort distance. So the distance that you have to apply the force when using the machine, divided by the resistance distance, which is sort of the actual distance the object's going to move in the direction you're trying to get it. So in this case, what do you think the effort distance is for this inclined plane?
4 meters.
Raise your hand. Well,
4 meters.
4 meters. That's how far you need to drag this thing to use this inclined plane. What's the resistance distance, Bella?
2 meters?
2 meters. You're actually just getting it up 2 meters. So that gives this inclined plane a mechanical advantage of what? 2
meters. No, 2
Newtons.
Joules.
Joules.
What?
Wait a second. 2 meters.
2 rubies.
2 joules. 1 Newton. Newtons.
What you do
Newtons.
to numbers in a formula,
Meters squared.
Joule meters.
you do to what?
Joules.
Meters per meter per
The
meter.
joules.
What
per
does that
second
equal?
times
Jeters.
Equals.
Anything divided by itself equals,
Equals self.
has no units. Meters divided by meters equals 1.
Meter.
There's no units. It's 2.
Damn, I was right. It's
There's no units for mechanical advantage. Nope. All right. So that's the ideal mechanical advantage. How about the actual mechanical advantage? So remind me of the formula that we use to calculate the actual. Meg? The resistance force divided by the effort force. The resistance force is basically the weight of the object you're trying to move. The effort force is the force that you apply to move that object. So in this case, what's the resistance force in our example? Raise your hand. Jack? 30 kilograms. That's how much this box weighs. What's the effort force that you're applying to use this simple machine? Luke? 16. You will need your calculator in this unit. You will. So what do you get here for the actual mechanical advantage of this inclined plane? Karina? 1.88, we'll round to 1.9. Now these are measurements of the mechanical advantage of the same inclined plane. Why do we get different numbers?
Because it's actual and ideal.
Well, what does that mean?
Like ideals, like estimate kind of, and then actual like the real thing.
Oh wait.
Yeah, you're right. What is this taking into account?
Friction.
Friction. Because ideally, in a friction-free universe, which does not exist, then mechanical advantage would be equal. But because you're dragging a box up a ramp, there's some friction between those two surfaces. As you guys found out when Mr. Farrell was here and you're doing your experiments on friction, that uses some of the force that you're applying, so you have to apply more force. So it doesn't quite help you as much as you would predict ideally, slightly less than that. Actual mechanical advantage will always be less than ideal mechanical advantage. All right, we use inclined planes all the time. Any type of ramp, any type of stairs are examples of inclined planes. You know what this is? Where this is?
Tokyo.
China.
These are the Spanish Steps. They're in Rome, Italy.
Why are they
Do you know what we call-
steps if they're not in Spain?
What's that?
Why are they
It's in Piazza di Spagno, I think. So if you ever have gone hiking, say in a relatively high mountain, if you go in the Adirondacks, you go up Bald Mountain or Black Bear Mountain or Blue Mountain, the trail that you follow doesn't just go up the mountain, right? The path that you follow to get up a mountain in a hiking trail, they're called switchbacks. They go across the mountain, then back across again, and back across again. Eventually you'll reach the top. That's an inclined plane. So the purpose behind those switchbacks is what?
So it's not as steep.
Yeah, it's not as steep. You can use less force. But again, it's a much longer distance. To get up this mountain, you could go straight up a very steep hill, or you can follow these switchbacks, but you're going to be walking a much greater distance, however you use less force. If you imagine, like in the front of our school, we have a wheelchair accessible ramp next to the stairs in the front entrance. So the stairs are their own inclined plane. What is the wheelchair ramp like? It doesn't just like go on this, like the stairs are here, it just doesn't go like this.
No, it's like
It's a ramp.
Yeah.
It kind of bumps.
It's a longer inclined plane. It goes out, curves around, and then comes back. That allows a person that's using a wheelchair to not have to exert so much force to get up those stairs. You don't have a ramp that's just the exact pitch of the stairs. It would be too difficult. So again, it's an inclined plane. Okay. Any questions about inclined planes?